All right, guys, Mr. Antonucci here, and in this video, we are going to start talking about applications involving motion along a line. In particular, we're going to talk about how to use an integral to find the total distance traveled and net displacement of an object moving along a line. So we have some displacements here. Basically, if you have an object moving with velocity v of t, and v is continuous on the interval a to b. Net displacement is defined as the integral of velocity over that interval, and total distance traveled from a to b is given by the definite integral from a to b of the absolute value of velocity. Also, if the velocity is non-negative on that interval, then net displacement is going to equal total distance traveled. In other words, remember, velocity and speed are not the same thing. Speed just tells you how fast you are going, but no direction. Velocity tells you how fast you are going and which direction. So velocity can be positive or negative, and speed is the absolute value of velocity. So a quick example that I like to use is net displacement. Let's say you started at your door, took 5 steps forward, 3 steps back. Your net displacement is 2 steps because you are 2 steps from your door from where you started. That's your net change. Your total distance traveled, however, would be 8 because you took 5 steps forward and then 3 steps back. Okay, that's going to be the distinction between net displacement and total distance. However, if you took all 8 steps forward and no steps backward, then your net displacement and your total distance would be equivalent in that case. All right. So let's take a peek at an example here, interpreting an integral involving motion along a line. So an object is moving along a horizontal line with velocity v of t in meters per minute from 0 to 6. We want to find the net displacement of the object from 0 to 6 and interpret the results. So that's the first thing we're going to do here. The net displacement, so for part A here, is going to be the integral from 0 to 6 of v of t dt. All right, so we have the integral from 0 to 6 of 3t squared minus 18t plus 15 dt, which is going to be t cubed minus 9t squared plus 15t evaluated at 0 and 6. All right, and then you plug in 0 and 6, and you would end up with negative 18. So after moving from t equals 0 to 6 minutes, the object is 18 meters to the left of where it was. So this would be negative 18 meters. And what we mean by that is that since the object is moving along a horizontal line, it's left and right movement. So it's 18 meters to the left is how you would interpret that answer there. So if for part B, however, we want to find the total distance traveled. So for this one, this would be the integral from 0 to 6 of the absolute value of v of t dt. Now the problem with this is that the velocity may take on negative values on this interval. So to do that, we can take the velocity function, 3t squared minus 18t plus 15, set it equal to 0, and factor it. So if you take out a 3, you would have t squared minus 6t plus 5 equals 0. And then 3 times t minus 5 times t minus 1. So that means that the velocity is 0 at t equal 5 and t equals 1. So what we want to do is figure out if the velocity is positive or negative on these 3 separate intervals. So velocity is going to be, so if we think about like a timetable here, 1 and 5, if you have a time before 1 and you try that time in the velocity, so like let's say at t equals 0, okay, the velocity is going to be positive. Okay, you could look at it in the factored form right here. If you plug 0 in there, you're going to get a positive number. Pick a number between 1 and 5. Let's say 4. If you plug 4 in there, you have 3 times negative 1 times 3. so the velocity is going to be negative. Pick a time after 5, let's say 6 or even 5.5, something like that. Make sure you stick to the interval that the integral is on. Then the velocity is going to be positive again. Okay, so basically what we're doing is we're describing the movement sort of the object. So for the first second, it's moving to the right. Then from seconds 1 to second 5, it's moving to the left, and then moving again to the right after 5 seconds. So in terms of figuring out or computing this integral here, we would have to do the integral from 0 to 1 of v of t dt minus the integral from 1 to 5 of v of t dt plus the integral from 5 to 6 of v of t dt. And after you anti-differentiated, plugged in all the values, and then simplified, you would get 46. Okay, now with units, this 46 means that the total distance traveled by the object is 46 units. Now, the reason we had to subtract this integral is because on that interval, the velocity was negative on that interval. So the integral is going to give a negative value. So if we take the opposite of it, it would give you a positive value. Now I want to show you how to do these on Desmos, because you may get a question like this on the AP free response section where you're allowed to use calculator or Desmos. So let me bring that up for you. Okay, so we have our velocity function here graph. Notice it's a parabola, but when we looked at it on the interval 1 to 6, we noticed that from 0 to 1, the velocity was positive. Then from 1 to 5, the velocity was negative. And then from 5 to 6, the velocity was positive. How you do this is, once you have the function in here, I would recommend naming it v of t, then type in int, gives you the integral, you can put the limits on, and then you can just type v of t in there, and then dt, it's going to give you negative 18. That would be the net displacement. If you do int, same thing, 0 to 6, and then the absolute value symbol, v of t, close the absolute value symbol, put the dt on, and you get 46. That's how it does it very quickly for us. Now, if I put in here absolute value of v of t, maybe I have to put y equals in there. Notice the graph, let me change the color here to blue. What the absolute value of velocity does is it creates a graph in which all the velocities are reflected over the x-axis that were negative. Okay, and then if we got the area under this blue graph from 0 to 6, it would equal to 46. So when you're taking the absolute value of velocity and integrating that, you're really doing the integral of the speed of the object. All right. Right, example 2 here, we're going to use integration with motion along a line again. Here we have another velocity function. If the position of the object at t equals 0 is s of 0 equals 3, find the position of the object at t equals 6, and then we'll do the rest of this. So for part A here, okay, s of t is going to be equal to the initial position plus the net displacement from t sub 0, the initial time, to whatever time of the velocity function. Okay, so s of t naught is 3. Okay, that's the initial time, is t equals 0, so the position is 3. And then we're going to have plus the integral from 3 to t of t squared minus 8t plus 5 dt. Now this right here is a function in terms of an integral, and this is good. Sometimes you're asked to express a function as an integral. This would be the way to do it. The 3 represents the initial position, and the integral represents the change in position. But if we integrate this, if we want to figure out, s of 6, then that's going to be 3 plus the integral from 3 to 6 of t squared minus 8t plus 5 dt. All right, so 3 plus 1/3 t cubed minus 4t squared plus 5t evaluated at 6 and 3. And then we're going to subtract, and all of that would boil down to negative 39. Okay, so at time t equals 6, the object is at negative 39 units, whatever the units would be in this case. All right, so for part B, we want to find the total distance traveled over this interval. Oops. So B, that's going to be the integral from 0 to 6 of the absolute value of v of t dt. And again, what we could do is factor this, figure out the intervals where the velocity is positive and negative over the interval from 0 to 6, and then break it up into separate integrals for those intervals. And then intervals where the velocity was negative, take the absolute value of those, or the opposite of those, and then add them all together. However, we're just going to show you how to do this on Desmos real quick. Okay, so we're back in Desmos, and I've entered the function to get the total distance traveled. We do int from 0 to 6, absolute value symbol, or you could type ABS and then parentheses v of t, oops, and then dt, and you would get 45.310. Now make sure on the AP exam that you're going out at least 3 decimal places of accuracy, and you're going to round to 3 decimal places or just chop it off. Either one is fine. For this one, however, you could write 45.31 because the 3rd decimal place of accuracy is 0, so it doesn't matter whether you put 0.310 or 0.31 for that one. But if we look at part C here, it asks what's the net displacement of that object over the same interval. So that's as simple as int for the integral 0 to 6 v of t dt, and you get negative 42. Now, an important point with this is on the AP exam, in order to get credit, you have to have the correct notation. Whereas, for part B, all you have to write is that integral, and then you could write 45.310. And then for part C, the net displacement would be the integral from 0 to 6 of v of t dt, and that's negative 42. Of course, if it's in context, you want to give the units on those numbers. And if it asks you to interpret it, make sure you're interpreting it there as well. And a tip for the AP exam is not all of the calculator allowed parts need a calculator. So when it's possible, sometimes it's faster to do the work by hand. And you may not even need a calculator for all the different parts. So just keep that in mind as you work through those. All right, guys, that's it for this one. Reach out if you have any questions.